Hi, welcome to the video. In this video I am going to discuss the quadratic forms and its canonical forms. Okay, what is a quadratic form? A homogeneous quadratic polynomial in n variables, that is x1, x2, etc. xn, is called a quadratic form. Okay, it is a summation. So a quadratic form is usually denoted by capital Q or small q in the components x1, x2, etc. xn of a vector capital X is a sum of n square terms, namely q equal to capital X transpose A into X, which is equal to sigma j equal to 1 to n and sigma k equal to 1 to n a j k xj xk. So this will be a summation form which consists of n square terms, that is equal to a11 x1 square, that is x1 into x1, plus a12 x1 x2 plus etc. plus a1n x1 xn plus a21 x2 x1 plus a22 x2 square plus etc. plus a2n x2 xn plus etc. plus an1 xn x1 plus an2 xn x2 plus etc. plus a n. Here is a correction. This is not a2n. This is a n xn square. So this sum is called the quadratic form. It is a polynomial in the components x1, x2, etc. xn with n square sums. Here this quadratic form can be represented in a matrix. The matrix representation is, here we have x1, x2, etc. xn variables. So first of all write the variable matrix in row model. So x1, x2, etc. xn. This is a row matrix. Then matrix A. A is the coefficients of x1, x2, etc. xn. So the elements will be a11, a12, etc. a1n. Then second row a21, a22, etc. a2n, etc. The last row is an1, an2, etc. ann into again this x, that is column model x1, x2, etc. xn. So this is the matrix representation of the given quadratic form. Okay, given a quadratic form, we can represent this in the matrix form in an infinite number of ways. If we choose a real symmetric matrix, then the above representation is unique, that is a summation representation. Okay, then that matrix is called symmetric matrix representation of the quadratic form. Okay, depending on the values of constants in this quadratic form, if it is in two variables, it can represent a parabola, an ellipse, hyperbola, circle, etc. If in case of three variables, this quadratic form represents equations of the plane curves and surface, etc. This can be discussed in some problems. Okay, then moving to an example, we have x transpose ax, that is a quadratic form in the matrix form, that is x1, x2. The matrix is 3, 4, 6, 2 into x1, x2. Then what will be the quadratic form of this matrix? This will be 3 x1 square plus 4 x1 x2 plus 6 x2 x1 plus 2 x2 square, the normal matrix multiplication. Okay, then here we have 4x1 x2 plus 6x2 x1. In the quadratic form, x1 x2 is same as x2 x1. Similarly, x1 x3 is same as x3 x1, etc. So this can be add up. So this will be 3x1 square plus 10x1 x2 plus 2x2 square. So this is the quadratic form representing this matrix. Okay, again from this quadratic form, how to write its matrix form? Okay, given this as the quadratic form, we want to write the matrix form. This is an easier way. Here 3x1 square. 3x1 square means 3x1 into x1 plus 10x1 x2 plus 2x2 square, that is 2x2 into x2. Here we have two variables, totally two variables x1 and x2. So the matrix corresponds to this quadratic form will be a 2 by 2 matrix. Okay, important one. If the quadratic form has two variables, that is x1 and x2, then the matrix corresponding to this will be a 2 by 2 matrix. Okay, if the quadratic form contains three unknowns, that is x1, x2, x3, then the matrix corresponds in the quadratic form will be of 3 by 3 order. Okay, then here x1, x1, this corresponds the 1/1th position of the matrix. Okay, similarly x2, x2, this corresponds the 2/2th position of the matrix. Then what will be x1, x2? x1, x2 will be shared in the position 1, 2 and 2, 1. Okay, we have already mentioned that x1, x2 is equal to x2, x1. Okay, so this value, this coefficient shared in the positions x1, 2 and 2, 1. So a general 2 by 2 matrix is A11, A12, A21, A22. Then write the corresponding coefficients. Here A11, 1/1th position's coefficient is 3. So write 3 as the first element. Then A22, 2/2th positions here. Okay, the coefficient is 2. So 2/2th position is 2. Then we want to write the elements in A12 position and A21 position. Here the coefficient of x1, x2 is 10. We can distribute this value equally in the position 1, 2 and 2, 1. So this will be 10 by 2, that is 5, 5. This is also a matrix representation of the given quadratic form. So the quadratic form's matrix representation will be x1, x2, then 3, 5, 5, 2 into x1, x2. This also is another matrix representation of the given quadratic form. Here 3, 4, 6, 2. Okay, given a quadratic form, we can represent them in the matrix form in an infinite number of ways. This is one way and this is the another way. This will be this only change in the matrix. Okay, so this is a matrix representation of a quadratic form. Then next one is principal axis form. It states that for any quadratic form Q equal to x transpose AX, it can be transformed into Q equal to lambda 1 y1 square plus lambda 2 y2 square plus etc. plus lambda n yn square is called the principal axis form or canonical form or diagonal form, where lambda 1, lambda 2 etc. are the eigenvalues of the corresponding matrix A and y1, y2 is the some vector. So this form, that is Q equal to lambda 1 y1 square plus lambda 2 y2 square plus etc. plus lambda n yn square is the principal axis form or the canonical form of the corresponding quadratic form. Note, if you are given a quadratic form, we can find the rank of the matrix, index of the matrix, etc. Rank will be the number of non-zero eigenvalues. Okay, in the earlier chapters we discussed that the rank of a matrix is the number of non-zero rows in the given matrix. Okay, if we have eigenvalues, then number of non-zero eigenvalues will be the rank of the matrix. Then index, number of positive eigenvalues. Then the triplet n0, n plus n minus is called the signature, where n0 means number of zero eigenvalue, n plus is number of positive eigenvalues, n minus is the number of negative eigenvalues. Then what will be the nature of the quadratic form? Depending on the eigenvalues, we can predict the nature of the given quadratic form. First one, positive definite. If all the eigenvalues are positive, then the quadratic form is of positive definite. If all eigenvalues are negative, then it will be negative definite. If we have the eigenvalues positive and 0, then it will be positive semi-definite. Then eigenvalues are 0 and negative numbers, then it will be negative semi-definite. These are the nature of quadratic form. Then indefinite means the eigenvalues are positive, negative, plus 0. Okay, then this will be indefinite quadratic form. Moving to problem. Find the rank, nature, signature and index of the quadratic form 3x square plus 5y square plus 3z square minus 2xy plus 2xz minus 2yz equal to 0. Here there are three unknowns, that is x, y, z. So the matrix will be of 3 by 3 order. Okay. Then x corresponds to position 1, y corresponds 2 and z corresponds 3. So 3x square. X square means x into x. So x into x corresponds the 1th position, A11. Okay, 5y square is y into y, that is y corresponds 2, so 2th position. Z corresponds 3, z square is z into z, so 3th position. Then next, x into y corresponds 1/2 position, here 1/3 position and this will be 2/3 position. Okay, let me write the matrix. It will be a 3 by 3 matrix. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. First of all, write the diagonal elements. Diagonal elements means x square, y square, z square is coefficient. That is 3, 5, 3. Okay. Coefficients of x square, y square and z square. Next, moving to the next number, that is minus 2xy. xy corresponds 1, 2. So 1/2 position is same as of 2/1 position. Okay, distributed equally. So minus 2 divided by 2. It is minus 1. So minus 1 is the element in the 1/2 position and 2/1 position. Okay. So minus 1, minus 1. Next one. xz corresponds 1, 3. Also 3, 1. Coefficient is 2. That is 2 by 2 is 1. So the number will be 1, 1. Then we need 2 more numbers. Here yz corresponds 2, 3. Also corresponds 3, 2. Coefficient is minus 2 divided by 2 is minus 1. So this will be minus 1, minus 1. So this is the matrix corresponding to this quadratic form. That is 3 minus 1, 1, minus 1, 5 minus 1, 1 minus 1, 3. We want to find the rank, index, signature, etc. Okay, depending on eigenvalues. So first of all, find the eigenvalues. This is the characteristic equation. S1 is equal to 11, S2 equal to 36, S3 equal to 36. Therefore, the characteristic equation becomes lambda cube minus 11 lambda square plus 36 lambda minus 36 equal to 0, lambda equal to 2, 3, 6. Here the matrix is 3 by 3. So you have 3 eigenvalues. Depending on this eigenvalues, we can predict the rank, index, signature, etc. Okay, here all the eigenvalues are positive. Okay, here lambda is equal to 2, 3, 6. All the values are positive. So the nature will be positive definite. Then what about rank? Rank is number of non-zero eigenvalues. Here we have all the eigenvalues are non-zero numbers. So it will be 3. Okay. Index. Index is number of positive eigenvalues. We have only 3 positive eigenvalues. So index is equal to 3. Next, what is signature? Signature is a triplet n0, n plus, n minus. Here we have no 0 as an eigenvalue. So n0 will be 0. And what is n plus? It is the positive eigenvalues. Here we have 1, 2, 3. So 3 positive eigenvalues. What about negative eigenvalues? No. Okay. So 0. So answer is 0, 3, 0. So this is the rank, index, signature and nature of the quadratic form. Second problem. Write the canonical form of the quadratic form. Q of x, y, z is equal to the same quadratic form as we discussed in the first problem. Hence, show that Q of x, y, z is greater than 0 for all non-zero values of x, y, z. This means Q of x, y, z greater than 0 means it is positive definite. Okay. Positive definite means all the eigenvalues are positive. In the previous problem, we discussed this same quadratic form that we get lambda equal to 2, 3, 6. All the eigenvalues are positive. So this is a positive definite, which means Q of x, y, z is greater than 0. The same answers. Okay, go through this. Okay, lambda equal to 2, 3, 6. All the eigenvalues are positive. So the canonical form. Canonical form is Q equal to lambda 1 y1 square plus lambda 2 y2 square plus etc. plus lambda n yn square. Lambdas are 2, 3, 6. So replacing this by 2. So 2 y1 square plus 3 y2 square plus 6 y3 square. Here the lambda is 2, 3, 6. All the values are positive. Therefore Q is greater than 0 for all non-zero values of x, y, z. Which means the quadratic form is positive definite. Next problem. Find the rank, nature, signature, index and the canonical form of the quadratic form x1 square plus x2 square plus x3 square plus 2x2 x3 minus 2 x1 x2 equal to 0. Here we have 3 variables. So matrix will be 3 by 3. Okay. Then what are the diagonal elements? x1 square. So 1, 2, 1 are the diagonal elements. Here 2, 3. 2, 3 and 3 to the positions will be same. Coefficient is 2 divided by 2 will be 1. So 2, 3 and 3, 2. 2, 3 and 3, 2. So 1 is shared here. Then what about x1, x2? x1, x2 means 1 to the position and 2 1 to the position. Coefficient is minus 2 divided by 2 is minus 1. So 1 to the position is minus 1 and 2 1 to the position is minus 1. Else the other numbers will be 0. So this is the matrix A. Okay, then find the eigen values. Characteristic equation is lambda cube minus 4 lambda square plus 3 lambda equal to 0. We have lambda equal to 0, 1, 3. These are the eigen values. Then nature. Here 1 and 3 are positive and including 0. So this will be positive. If 0 has an eigenvalue, then the nature will be semi-definite. So this quadratic form's nature is positive, semi-definite. Okay, then what will be the rank? Number of non-zero eigenvalues. Number of non-zero 1 and 3. So number is 2. What is the index? Number of positive eigenvalues. That is 2. Because 0 it is considered both positive and negative. So we have 2 positive eigenvalues, so index will be 2. Then signature n0. What is n0? Number of 0 eigenvalue, that is 1. N plus positive eigenvalues as 2. N minus we have no negative eigenvalue. So 1, 2, 0 is a signature. And the canonical form, q equal to lambda 1 by 1 square plus lambda 2 by 2 square plus etc. plus lambda n y n square. We have 3 eigenvalues. So 1 y1 square plus 3 y2 square plus 0 y3 square. That is equal to y1 square plus 3 y2 square is the canonical form. Next problem, this is a university question. Find a matrix C such that this quadratic form. Okay, find the matrix C. We have q equal to x transpose A into x. Here A is given as C. So we want to find the corresponding matrix related to this quadratic form. So simple. Okay. First of all, write the quadratic form in the matrix method. So this matrix corresponds our C. Okay. Here this is the transformation, means the quadratic form. Here x1 square's coefficient is minus 3. So the first diagonal will be minus 3. Second will be minus 1 because minus x2 square. Minus 5x3 square, so minus 5. So these are the diagonal elements. And x1, x2, the coefficient is 4 divided by 2, 2. So 2 is distributed in 1 2th position and 2 1th position. Then x1, x3, coefficient is 2. So 2 by 2 is 1. So 1 is shared here and here. Then other elements will be 0. So this is the matrix